Welcome to Electronic Geek. In this video, we will see about current divider rule. I will be demonstrating this rule with the help of a fully resistive network. It is quite a useful tool for analysis as well as for design purposes. So let's see what is current divider rule. So this is the circuit that we are going to analyze today. So here we are having a 24-volt DC source and two resistors of 1K and 2K connected in parallel across the source. So we all know that when resistors are connected in parallel across this voltage source, the voltage across the resistors remain the same. What changes is the current flowing through each resistor. We all know that larger the resistance, less current flows through it, and smaller the resistance, more current flows through it. Resistance is inversely proportional to current. So what we are going to do is derive a general formula which can be applied to such a network to find out the current flowing through each resistor. If you see over here, current I is the current that is being supplied by this source, okay, of 24 volt, and this current I is bifurcated into these two branches as IR1 and IR2. So let's see over here. By basic KCL, okay, Kirchhoff's current law, we can see that I is equal to IR1 plus IR2. So current flowing through this resistor, that is IR1, is equal to V, that is this voltage source, divided by this resistance R1. Similarly, IR2, that is current flowing through this resistor, is equal to voltage divided by this resistance. Now, if you add IR1 plus IR2 and you substitute it in this equation, what you get is total current I is equal to V by R1 plus V by R2. Take V common, so inside you are having 1 upon R1 plus 1 upon R2. So V is equal to I by this whole term. Okay, take it over here. And if you solve this part, what you get is R1 plus R2 upon R1 R2. That R1 R2 will go up and it will become I into R1 into R2 upon R1 plus R2. This is equal to V. Now talking about individual branch currents, then that is equal to, okay, we saw earlier that IR1 is V by R1. So substitute this whole term, okay, in place of V. Then IR1 comes to be IR2 upon R1 plus R2. Okay, do the same thing for IR2, then you get IR1 upon R1 plus R2. Okay, so this is the basic method of finding out the current through each branch. Now, one thing to notice over here is that current through any branch is equal to current supplied by this source into parallel combination of these two resistors, okay, divided by the branch in which you want current. So I want current in branch R1, then my equation will be that current supplied by this source multiplied by parallel combination of these two resistors divided by this resistance, that is 1K. So let's solve this circuit. So first thing that we have to find out is the current supplied by this source. And in order to do that, what we do is we will take the parallel equivalent. So 1K and 2K in parallel, if you do R1 into R2 upon R1 plus R2, what you get is 666.67 ohms. So the total current supplied by this source is going to be 24 divided by 666.66, and let's see how much that is. 24 by 666.67, that is 35.99 milliamps, so we can consider 36 milliamps. So the source is supplying 36 milliamps, okay, and it is getting bifurcated to two branches. Now by the formula that I told, the current through this branch, okay, through 1K is going to be 36 milliamp into 666.67 divided by 1000. Let's see it. So 0.036 into 666.67 divided by 1000. So what you get is 24 milliamps, and 24 milliamps are going through this resistance, which means 12 milliamp should go through this resistor. Let's simulate and check the answer. So see, it's 36 milliamp. You can see now current through this is equal to 24 and through this is equal to 12. Now, what approach will you use if you have more than two resistors? Okay, so nothing changes much. What you have to do is you find the equivalent of all the resistors in parallel, multiply it by the current flowing through source, and divide it by the resistance of that particular branch in which you have to find the current flowing. That's it. So this is it for this video. Thank you for being till here. Thank you so much. Please do like, share and subscribe to my channel. If you have any doubts or suggestions, feel free to put it in the comment section. Thank you for being till here. Thank you so much.